All right, I guess we'll get started. I only have 20. I have 40 slides, but then I realized the sessions. I thought it was 40-minute sessions. I was like, so I'm going to have to go through kind of quickly, which means nobody can ask any questions. No, I'm just kidding. So we're going to talk about this kind of follow-on. Alexei introduced it in his last slide about using Blueprint in OpenDaylight. In Boron, we added support, extensions, and infrastructure so that we can easily use Blueprint in OpenDaylight. And the core is of MVSal, and the core of the controller is all is now all Blueprint, but also supplying the config system services as well for the compatibility with that. So what is Blueprint? For those who don't know, it's a dependency injection framework similar to the config system. For those who have coded to that, similar ideas but implemented very differently. It is, and it's a spec as well. It's an OSGi compendium spec. So Blueprint itself is a spec, actually. And it is designed specifically for use in OSGi container, unlike other frameworks. Goose and DAG, Juice and DAG. So it is actually derived from, for those who have used Spring in the past, Spring IOC. Spring DM was a project that Spring back like 5 or 6 years ago decided to get out of OSGi. They didn't see any future in it. As we know, there has been a future with it. So they donated Spring DM to OSGi compendium, and then they derived the Blueprint spec from that like 6 years ago. So basically, it's just like Spring. It's very similar to Spring. It uses XML files as resources in your bundle to instantiate your business logic and wire things together and do all that fun stuff. So why Blueprint? Well, it's a well-documented OSGi standard or spec, and the Apache Aries is the implementation. That carafe comes already installed and all ready to use, so it's very easy that way. And it's relatively easy to understand and use. I guess maybe that depends on your perspective, but I find it very easy to use. The XML is pretty simple, and and it's patterned right after Spring. So I think it's so I feel it's, as far as usability, it's an upgrade over the config system. I think many who have coded the both would probably agree with that. And it also helps with our upgrade story. And that was the main impetus for switching over to Blueprint. We found for those trying to create distros, it was difficult with the config system. And again, I'm not going to go into too much detail on the why here, but it makes things easier because your code wiring, you separate code wiring from the user configuration, which I think was one problem for the config system. It was all munched into the same model, and so you run into the problem where in an upgrade, well, you want to preserve any user configuration, but you want to pick up the code wiring changes in the new release. So we ran into problems with that. So yeah, code dependency wiring is embedded in the bundles, as we'll see. So inside of carafe, there's what they call the Blueprint extender, and that is the component that basically scans bundles as they're activated. It looks for Blueprint XML files, and then parses them and creates Blueprint containers and instantiates all your logic and everything. By default, it looks in the OSGi inf/blueprint path inside your bundles. We've been using our own path inside of the bundles. The reason for that was so that we could have more control over, how the containers are created. We could possibly do ordering like the config system did. We haven't, the way they're loaded from the features, we could do that. We haven't seen a need to do that, but just in case, to allow us to, for more control, we've been using the convention of putting them in our own well-known path. So basically, OpenDaylight just extends the extender and looks in our own path. So let's move on to the next one. So in a blueprint XML file, it's pretty simple. There's basically these 4 basic elements, top-level elements. One's called a bean, and a bean is just a Java object. It describes how to create a Java object of your class, and you passing in the constructor arguments and any properties calling the setters. Service is how you advertise a bean or service implementation as an OSGi service. So it's a very simple tag element that just advertises at the OSGi service registry, and reference is the opposite. It imports a service from the OSGi registry. Reference lists, I'm not going to really go into that. That's basically how you can, so reference imports a singleton. It's going to get the single service. If there are happen to be multiple, it's going to pull the first one it finds. But typically, you're not, you can't have multiple implementations, but the one you pick, you can do it by filters and stuff. Reference list says, get me all the implementations of this interface, all OSGi servers. That might be something for like listeners. You have clients register listeners as an OSGi service, and then in your core end, you can use a reference list again because you want to gather them all and put, so you can notify them all. So, kind of example why you'd use that. So here's an example. I'm just going to go right into an example of how to use the bean element. So we just have simple 3 classes here, call them foo, bar, and baz. So the bar class takes a foo instance as in the constructor, and baz takes a foo instance via a setter. So I'll show you how you can very simply wire this stuff together. So the top level element has to be blueprint, and with the name, the blueprint namespace, and then we see, and then I can use this thing. So now we create foo. So basically, all we do, so the bean element, in the very simplest case, you just give it a class name. That's it. And it's going to create an instance of that class, in this case using the default constructor with no args, and it's going to put it into a bean with the ID of foo. So whatever you want to call it. So ID equals foo. It's just an identifier for the container for that bean, which can be referenced later on in other beans, and we'll see that in a moment. So now I'm going to create an instance of class bar and give it ID bar. Now this is where, now we saw that in the code that bar takes an instance of foo in the constructor, and this is what we're doing here. Arguments, you list your argument tags for however many constructor args you have. Ref equals foo means, so ref means reference another bean by its ID. So we've already created a bean with ID foo, so now we're going to reference it to get it passed in as an argument. And now baz, I had it as a property instead of in the constructor. So it will also, you can specify property, which is basically, it uses the Java beans convention of, the property name is foo and set foo, so basically the method name, it looks for the method name set with and then capitalizes the first letter. So it uses the Java beans convention there. So it's going to look for a set foo method. And then again, we're passing in the reference of the foo. So that's going to get the foo instance and pass it in as the argument to the set foo method. So is that pretty clear? Or pretty simple, right? I think so. And there's a couple other fancy things you can do with beans as well. So, there are cases where, you might have a static factory method in a class. So here we have a static method called new instance on foo. This is a pattern that people will use sometimes. So you wonder, well, so in this case, I don't want it to call the constructor of foo. I want it to call the new instance method. So in the example down here, we have, bar. We're going to create an instance of bar, and and we're going to call new instance method with the bar instance. So here, instead of, we give it the class of foo, but we give it factory method equals new instance. So that tells it, don't construct an instance of it using a constructor. Call this method, new instance method, and the static method on this class, and pass it any arguments that it takes. In this case, we have to give it an argument of bar. So that's another pattern that is pretty common. And yet another one is when you have a factory class. So here we have a class, a foo fact. We have a separate class that creates instances of foo, the foo factory. So that has the new instance method, which takes bar, and you can see very similarly. I forgot to give the class. No, I don't need. Oh, I'm sorry. I don't need to give class in this case. So basically, I'm creating the foo factory instance, and now what I'm going to do is I give it factory method like before, but I don't need to give it a class name because I'm actually giving it the instance of a actual bean called foo factory that has the method new. So basically, it's going to take the foo factory bean and a reference by the ID here, and it's going to reflectively look for the method new instance on it, and it's going to invoke that method and pass it bar. So this is a different pattern for doing that. So you're actually taking another bean and calling a method on it to construct an instance of an object. Is that pretty clear? So it's pretty flexible. You could also have init and destroy methods, which is a very common pattern. So they actually built it right in. So you can say init method equals, so whatever the method name is, you make it up. I used init and destroy. Not very, it's very straightforward. So basically, the method here has to be a public method and no arg, takes no args. So this is what they would look like, and very simple, init and destroy. And those are, so init is created after the instance of is created, and all the setters are called. Then it's going to call the init method. And destroy is called when the blueprint container is being destroyed on shutdown. It's going to call all of the destroy methods on the beans. All right, so go. Okay. I'll just go. I'm going to go with it really quick. Maybe I won't go. Well, this is some examples of how to use argument. There's different. We saw ref. We pass in the idea of another bean. You can pass values, straight hard-coded values in. You can also give it the type. Sometimes you may need that to disambiguate between other constructors, which may have, say if you have a constructor that takes a long and one takes an int, you need to disambiguate them, if that's a word. And you can also, this is a shortcut value to give it, so passing in the value of 10. Here I'm doing this same thing, but it as a sub-element of argument, so it's pretty flexible. If you need to pass in null, you can't just, you have to use a special keyword. There's this special element called null to pass in null. And that's not very common. You would do that, but there are cases where you might need to. And you can inline beans as an argument. So I can actually, instead of creating the bean as an outer element and referencing it by its ID, I can actually just inline the bean right here. So it's only used, so it can only be referenced here and passed in. But that's useful if you just need it in one spot. You just want to inline it. And same thing, I could actually call here I'm calling the get value method of another bean, and I'm going to pass that value in as the argument. So you can call other methods on other classes. And a list, this is very, so if you got to pass in a Java that util list, it has support for that via the list tag. And then you just give the values of the list, which can be values, refs, beans, or even another list. It also does set, set, java.util.set, you just call it set, and then pass the values in. Array, supports an array type, and maps. If it takes a map, you can actually create a map with the entries in there, and you just give it the key values. Keys cannot be null. I won't go into this too much detail because I gotta move on. So reference, the reference element, so that takes care of the bean element. Any questions on that?
Yeah, I have two questions. The first one is related to annotations. So there's any way to avoid using XML? Because I've been working with some XML stuff and the blueprint stuff. And it's like when we do some refactoring, it's kind of hell sometimes.
That's a downside. That's a downside to it. Annotations, you're going to talk about that tomorrow, right?
Join the session tomorrow at 3 o'clock.
Yeah, so that's the next step is Blueprint or Aries does support the standard like at inject and at singleton does support annotations as well. I wasn't going to go out into that here. I'm just but Mike's has a session on that, and you've been exploring that. So we haven't adopted it quite yet. We have to put some infrastructure in for it first.
One project that has started 3 or 4 annotations.
Yeah.
With no other projects to start taking over.
So we're getting there, and Blueprint does have, or Aries has support for that. So, reference element is allows us to import a singleton OSGi service, and the service instance is made available as a bean to the rest of the Blueprint container, so you can inject it into other beans. It creates a proxy because of the dynamic nature of OSGi. The OSGi services can theoretically come and go as bundles are stopped and restarted. And so what Aries does is actually creates a proxy under the hood. So what you're calling is the methods is actually on the proxy. So it automatically under the hood will swap out the implementations so you're not aware of it. That's disadvantages. There's advantages and disadvantages to that. And using Blueprint Wiki, it kind of goes into more detail on that. So I won't go, but anyway, suffice it to say it creates a proxy. So for the dynamic nature of OSGi. So reference services are treated as dependencies. So based on startup, the container is going to wait for all services to initially be satisfied. So it's going to block the startup of the Blueprint container until all service elements on all the services have been satisfied. That's if the services are labeled as mandatory. You can't have optional services, although I haven't seen too much use of that, but usually they're mandatory. So it's going to wait, and it's going to default. 5 minutes is the default timeout. If it fails the whole container. You're screwed. So anyway, but I did put in a retry, so we'll retry indefinitely in OpenDaylight rather than trying to just have an infinite timeout and having to do that everywhere. So later on, when you're using the service, it's theoretically possible as your code is calling the service class, the service instance, the proxy, the service goes away under the hood and there's no other service there. So the proxy is going to throw unchecked exceptions at you. So that's kind of first it blocks, I'm sorry. First it will block, and it will wait that timeout period for a new service to for a new service instance. Otherwise, it throws an exception. But you don't typically run into that because in OpenDaylight, we're not that dynamic with, starting and stopping bundles and all that, and, doing in-service upgrades and stuff. So examples of reference. So here is very simple. You give it the ID, and that's the bean. That'll be the ID of the bean in the container, and you give it the interface. So here we're getting our friendly binding data broker. And we're going to put it into so that's going to go out and get it from the OSGi service registry and wait for it. And then it's going to take that instance and stick it in there with bean ID data broker, and then which we can then inject into using, argument ref equals data broker or property, into other classes. You can also do filters. And the OSGi compendium has the syntax for the filters. It's I won't go into that, but you have to have the parentheses. But basically here, I'm saying I've made up some service property called type. And so I want the, yada yada service with this interface with type equal, with the service that's advertised with the service property type equal to foo. So that's how you can disambiguate service instance. You can have multiple service instances, and I'll show you that in a minute. In fact, right here. So service element, that's the opposite of the reference. So that allows you to advertise bean instances as OSGi services, and typically you usually give an interface. You can actually give multiple interfaces. So if the service implementation, could implement 3 different interfaces, and you want it advertised with all 3 interfaces. And let's see. So here we advertise a service with a single interface. Very simple. I just create the bean. So we got foo. Where are you, foo? Okay. So I just I create my foo impl, and I just say so I just ref using the ref element, the ref attribute. I reference the ID of foo, and I'm telling it to advertise foo, that object, with the interface, myapp.foo. Pretty simple. And here I'm doing multiple interfaces. So this is a shortcut with the attribute. This is most of the time, this is what you're only doing one interface. This will allow you to do as a sub-element, you can do multiple interfaces. Okay, so in OpenDaylight, so we have basically 2, like the binding data broker, as an example, and why this was added. So binding data broker, there's actually like 2 implementations of it. There's the normal one, which is the backed by the cluster data store, and for those who may be familiar with the ping pong data broker. So we have actually 2 data broker services that the MDSal advertises. So how do clients differentiate between that? Well, in the last example I showed with the type property, by type equals whatever. So we introduced this as a short, since to make it really easy to use the type property filter. I just added an extension attribute that can be attached to either service element or reference element, where you just say type equals blah, instead of having to do that filter syntax. And so just to make it really easy, I'll show you examples. As a convention, in core, we use type equal default for the default implementation of it. So for data broker, the default implementation is the cluster data store. So that kind of allows consumers to obtain, just say, I want the default implementation that the system provides. Whatever that is, I don't care what it is, I just want the default. So then you could easily switch out as the provider what the default is. Let's say we end up, it's a cluster data store 2 or something, so clients would just pick it up automatically if they just say type equals default. So here, the example. So this is our extensions namespace. So org OpenDaylight /blueprint. You got to have that in there. So, And so the namespace, and then I have to reference it by ODL, you know, you have to, just standard XML, you got to prefix it. So here I am advertising, this is actually what we do in core with the binding data broker and the ping pong. So we actually, so the normal cluster data store broker, I added, so this type attribute can be added to the service element and we give it the default. And here we actually create the ping pong data broker and we say ODL, you know, the type is equal to ping pong. So in your code to reference them, you know, you just use reference tag and then type equals default or type equals ping pong. And so that's basically it there. To make it simple, because so you got to specify a type. So rather than having to do that in every single service you import, you can just say at the top level blueprint element, you can just say use default for all reference types. And so it'll automatically put type equals default in there for you. Oops. Okay, good. All right, this is the good. So application configuration. Applications typically need user configuration. There's like two ways that we've done it. Using the OSGi configuration admin service, which comes with Carafe. That's basically reads your properties from CFG files under etc, and then the MD style data store, using that to store your user configuration. I'll just go over config admin really quick. So it's useful. It's simple. It is, it's a service already provided by Carafe, and as I said, the file that's stored in CFG files. Aries has nice blueprint extensions for interfacing with the config admin. The cons of using config admin is you're limited to just simple key value pairs, which probably in a lot of cases that suffices, but you may have more complex structures in which Yang allows you to do. So you're limited to simple key values. You really get no data validation other than if your code is expecting an int and you fat finger it, you'll get an error there, but you don't get any range validation, unless you build that into your code. You get no automatic validation like you do with the Yang. Configuration can't be updated by a REST comp, and also the configuration isn't clustered. You have to make the changes on each node. So Aries comes with the property placeholder extension, which is actually pretty easy to use. You just give it the persistent ID attribute, which is the name of the CFG file. And so on container start, it's going to read that file, and it's going to make all the properties in there, their key names, available as just a simple $ variables that you can just reference in your code, and it'll automatically substitute them in. And it can also dynamically respond to updates to that file. So if you change the file, it'll reload the blueprint container to get the new values. And here's just simple example. You have to, again, the namespace of the Aries extension for CM. They call it configuration manager or some blueprint CM. And there's the property placeholder. I give it the name of the CFG file under etc. And I can also give default values. So here I'm saying, specifying, let's say max retries is a key in my properties, giving a default value of 5, so that if the file's not present or that is not in there, it's going to give it 5. So here I can, if assuming I have a set max retries method on the foo class, I can just reference it with a $. So it's kind of cool. Is there any questions on that? So
that one was unrelated to I was is there any relationship with that and the CFG file? Or
what it's going to read the CFG file, that I give it, the persistent ID. So it's going to look and you don't give it the .cfg extension, but it's going to put .cfg. It's going to read that file, and if there's max retries equals blah in there, it's going to make it available as this variable to get passed in. Okay, so that's that. So MDSal, using the MDSal data store really quick. This is probably the more common one that we've been using, this pattern. We can use the rich structures that Yang provides. It's distributed, right? So you write it to the config data store, it's persisted, and it's distributed automatically for you. And you can modify it by RESTConf or NetConf, which has that's advantages there. And we can dynamically respond to updates by a data tree change listener. Not data change listener, right, Alexi? Data tree change listener. But so to help with all that, we have an extension in ODL called the clustered app config. So this will access the configuration Yang data. So you basically define a Yang model. It supports a top-level container or a top-level list element. Where I'll go over the list. It's where you might have multiple configurations of the same. You might have multiple instances of foo that you want to create, but each has their own configuration. We did that. I had to use that in OpenFlow because there's different. What is open? I forget what it was exactly. One's on different ports. There's two. They're listening on different ports. So, yeah, and so the binding class instance, so it's basically going to get it from the data store. And if it's not in the data store, it is going to, it will create a default instance of it using the default values from the Yang. So I just want to finish real quick, couple more. So it's treated as a dependency, just like OSGi services. So it's going to block the startup of the container until it can get read it from the data store. Either one way or another. Either the data's not there, but it wants a successful read from the data store. And it's going to block. Data store's not available. It's going to block the startup of the Blueprint container until it becomes available. It automatically registers a DTCL so that it will respond to updates to it, and it will restart the Blueprint container automatically for you. So here's an example here. So I got so I'm creating a Yang module with my foo config, top level container, and it has two attributes, ID and connection timeout. And so to use the clustered app config, basically, I reference it. It's a clustered app config. This is the name of the bean that is going to that the instance is going to be assigned to, and I just give it the binding class. So the generated binding class for that Yang model is going to be called fooconfig. So I just give it the class, and it's going to go read that class from the data store. And then, then I can take fooconfig, and I can actually just pass it in as a reference. So assuming foo, the argument takes a fooconfig instance, so I can just pass it in. Real quick. Default data. Sometimes your data is, say, more complex, and default values in Yang are applied to leafs. Sometimes you may have list structures, container structures you want to provide defaults for. So you can actually provide default XML right in the tag, as a child element. And this is the same XML that you would use to push it through RESTConf. Exactly the same thing. With the names, you give it the namespace and the attributes, foo and connection timeout. So in default data, we can also put it in an external XML file. So that XML I just showed you can be put in an external XML file. And very important, the default data is basically the initial data. So if it's not in the data store, no user has written it to the data store, then it's going to use that. But once it's written to the data store, it doesn't use the initial or default data anymore, which makes sense, right? So, the file is useful, very useful for scripting and test automation, where you want to set it up beforehand. I know the previous session ran late, so I got. And the default form, no, it was good though. The default format, so it's going to look in this well-known location. It says a static, so under etc OpenDaylight data store initial/config, you put the file in there with this, you can specify the name, but by default it's going to be yang module name underscore container name. So, and it's going to look for that file and it'll read it in and use it. So, and I think that's, I won't go over that. I'm going to put these up on, this is how to do a yang list. If I have multiple instances of something, so if I have a list, foo config is actually a list with the key is the instance name. You can actually, so here I have the first instance of foo. So I'm going to create two instances of foo. One with one configuration, one with another different configuration. So here's my first cluster.config, and with the list, you have to give it the key value for the key. So there has to be one key, and it has to be a string. That's the limitations right now. So I'm going to call it, so the key value is instance 1, so it's going to look for, in the data store, it's going to look for instance 1 in the list. And here I have to give the instance. So it's the same thing that you would do if you're writing it through RESTComp. And then I can have a second one with instance 2. So now I'm going to create another instance of foo with its own configuration, which is going to be referenced by instance 2 in the list. And I think that's, well, RPC implementations, really quick. So to make it easy to register RPCs, we have this tag RPC implementation. I just create the bean, and so if it implements an RPC service, you can just say implementation and then reference the bean. It's going to automatically find the RPC interface, service interfaces, and register it, and then closes it, the registration. So it's a shortcut. And routed RPC implementation, very similar thing. In RPC services, I want to consume an RPC service, so this makes it simple. I just, so it's going to create it and put it in a bean of type foo RPC service, which I can inject into, into other beans. I just give it the interface, the RPC service interface. And it's going to also, it creates it, and it treats it as a dependency, so it's going to wait for an implementation to be present in the RPC registry. That helps to avoid what Kamal calls Heisenbugs, where if your code on startup needs the service, but it's not yet there. So this is going to wait for it, so kind of neat. And notification listener. So this is, for Yang notifications. So around the register is a notification listener for this notification class. So, and I think that's basically it. That is it. So, sorry, I had to go fast. Is there any more questions? I know these folks are waiting. I'm sorry for taking the...
So the cluster config that you showed towards the end, where you could provide the configuration using that new service, is it to avoid the CSG file?
Yeah, as I mentioned, it has the advantages that it's clustered. It also provides more rich structures, Yang, than just simple properties, key values, and it's clustered. And you can set it through RESTComp, which CFG files you can't. So there's advantages to using it. Yeah.
Even to bootstrap a module, you don't require a CSG file. Is my understanding correct?
You don't need it. No, it's if whatever configuration your code needs. Whatever you define it. It's whatever you need for startup. Any kind of parameters you need to wire it up, and so. All right. I guess that's it. It uses XML files as resources in your bundle to to instantiate your business logic and wire things together and do all that fun stuff. So, so why Blueprint? Well, it's it's a well documented OSGi standard or spec, and and the Apache Aries is the implementation that that carafe comes already installed, and all ready to use, so it's very easy that way. And it's relatively easy to understand and use. I guess maybe that depends on your perspective, but I find it very easy to use. The XML is pretty simple, and and it's patterned right after Spring. So I think it's so I feel it's, as far as usability, it's an upgrade over the config system. I think many who have coded the both would probably agree with that. And it also helps with our upgrade story. And that was the main impetus for switching over to Blueprint. We found for those trying to create distros, it was difficult with the config system. And again, I'm not going to go into too much detail on the why here, but it makes things easier because your code wiring, you separate code wiring from the user configuration, which I think was one problem for the config system. It was all munched into the same model. And so you run into the problem where in an upgrade, well, you want to preserve any user configuration, but you want to pick up the code wiring changes in the new release. So we ran into problems with that. So yeah, code dependency wiring is embedded in the bundles, as we'll see. So inside of Carafe, there's what they call the Blueprint extender. All right, I guess we'll get started. I only have 20. I have 40 slides, but then I realized the sessions. I thought it was 40-minute sessions. So I'm going to have to go through kind of quickly, which means nobody can ask any questions. No, I'm just kidding. So we're going to talk about this kind of follow-on. Alexi introduced it in his last slide about using Blueprint in OpenDaylight. In Boron, we added support, extensions, and infrastructure so that we can easily use Blueprint in OpenDaylight. And quite the core is of MVSal, and the core of the controller is all is now all Blueprint, but also supplying the config system services as well for the compatibility with that. So what is Blueprint? For those who don't know, it's a dependency injection framework, similar to the config system for those who have coded to that. Similar ideas, but implemented very differently. It is, and it's a spec as well. It's an OSGi compendium spec. So Blueprint itself is a spec, actually. And it is designed specifically for use in OSGi container, unlike other frameworks. Goose and Dag, Juice and Dag. So it is actually derived from, for those who have used Spring in the past, Spring IOC. Spring DM was a project that Spring back like 5 or 6 years ago decided to get out of OSGi. They didn't see any future in it. As we know, there has been a future with it. So they donated Spring DM to OSGi compendium, and then they derived the Blueprint spec from that like 6 years ago. So basically, it's just like Spring. It's very similar to Spring, and that is the component that basically scans bundles as they're activated. It looks for Blueprint XML files, and then parses them and creates Blueprint containers and instantiates all your logic and everything. By default, it looks in the OSGi INF/Blueprint path inside your bundles. We've been using our own path inside of the bundles. The reason for that was so that we could have more control over how the containers are created. We could possibly do ordering like the config system did. We haven't, the way they're loaded from the features, we could do that. We haven't seen a need to do that, but just in case, to allow us for more control, We've been using the convention of putting them in our own well-known path. So basically, OpenDaylight just extends the extender and looks in our own path.